In this video, we're going to go over the review sheet for test 3. So the first question is asking which of the following could have a triangle as its cross-section? And the options are cone, cylinder, cube, and square pyramid. So just in order to see it better, I have each one of them pulled up. So let's see if we can find a triangle. So here's a square pyramid. And I see that if we slice it perpendicular to the base, we get a triangle. So square pyramid, you can definitely make a triangle with. So already that eliminates answer choice 1 because 4 it definitely works for. Let's check out cube after that. Okay, so let's see if I can find a triangle cross section of a cube. It's not looking like I can find one. Let me turn it. Yeah, I'm not seeing a triangle. I'm seeing some weird things, but no triangles there. I'm going to put that one on hold, but I'm thinking that 3 is not going to work. So I'm thinking probably answer choice 4 can be eliminated. So now I'm between 2 and 3. Okay, let's check out cylinder, and let's see if cylinder we can get a triangle out of. So, oops. Let me scroll that back up. There we go. I'm taking a look. No, I'm not seeing a triangle. Nope. So, not a cylinder. Okay. How about a cone? Let's check that out. There we go. We can definitely get a cross section from a cone. So 1 is all good. And take a look. The cube, if we slice it diagonally, we actually can get a triangle in the corner. You can make a triangle. You can draw a triangle in the corner of a cube where each of the corners are if you slice it slanted by the corner. So let me get rid of my slash through cube because that actually does work, as we just saw. So the answers are everything except for 2. So that would be 1, 3, and 4. So that is actually answer choice number 4. 1, 3, and 4. Okay. We're talking about a hexagonal prism over here. So first we're cutting it parallel to the base. Parallel to the base means horizontally, and it's going to be a hexagon. So I'm going to write that down. And let's just see a visual of why that's true. So let me pull that up. Okay, so we are doing parallel to the base. And as you can see, parallel to the base is the same shape as the base in a prism. So in a hexagonal prism, it would be a hexagon. Perpendicular to the base, let's see what it is going to be. Oops, wrong thing over here. Perpendicular to the base, we get rid of parallel, and we see that it is like a square, rectangle, same thing as the faces. So I'm going to put here rectangle, and it is the same shape as the faces if we're cutting perpendicular to the base, if we're cutting it vertically. True or false? This prism can have a triangular cross-section. That's true. Just like the cube, if I cut it at the corner with a plane, we can get a triangular 2D shape. So that's true. True or false? This prism can have a circular cross-section. Answer is false. There are no curved edges. Everything comes to a point. So there's no way that we're going to get a circle out of here because a circle doesn't have points. A circle has just curves. So out of a hexagonal prism, there is no way that we are going to get a circle out of that. Okay, moving down. We are told that AD is perpendicular to AE and that AD is perpendicular to AB. And I see the right angles here. Which plane is perpendicular to AD? So we're looking for perpendicular to this line. So perpendicular to this line would be one that forms a right angle with it. So it's either going to be over here or over here. Let's see which one is a choice. HEA. That's our first choice. BAD. That's our second choice. We have EAB. And we also have EHG, which is all the way up here. So we have found the correct answer choice. It is choice EAB because it makes a right angle with AD. Perpendiculars like this, it makes a right angle with AD. Okay, moving on to number 4. Lines K1 and K2 intersect at point E. Line M is perpendicular to lines K1 and K2. Which statement is always true? Lines K1 and K2 are perpendicular to each other. I know we don't trust diagrams, but that doesn't have to be true. And in the diagram, it doesn't look like K1 and K2 meet to form right angles, even though we don't trust diagrams. But I don't think we have any reason to believe K1 and K2 are perpendicular to each other. They're both perpendicular to line M, but that doesn't mean they're perpendicular to each other. It says in choice 2, line M is parallel to the plane determined by lines K1 and K2. Well, if line M is perpendicular to K1 and K2, then it intersects K1 and K2. Perpendicular means that they intersect to form right angles. So line M intersects K1 and K2. It's perpendicular to it, so it would also intersect the plane made by those lines. It's not possible to be parallel to the plane made by the lines that it's intersecting. So that choice is out as well. Moving down. Line M is perpendicular to the plane determined by lines K1 and K2. That is the correct answer. If M is perpendicular to lines K1 and K2, then that means that it also has to be perpendicular to the planes that are determined by those two lines that it is perpendicular to. Let's take a look at choice 4, which is not correct. Line M is coplanar with lines K1 and K2. They are not on the same plane. So answer choice 3 is the correct one here. Okay. Line K is drawn so that it is perpendicular to two distinct planes, P and R. So here's my line K, and it's perpendicular to plane P, and it's also perpendicular to plane R. What must be true about planes P and R? If line K is perpendicular to both planes P and R, then planes P and R have to be parallel. And hopefully my picture illustrated that. 6. Which three-dimensional figure will result when a rectangle is continuously rotated about the longer side? Just to illustrate this a bit better, when you have a rectangle and you rotate it or spin it really, really fast to make a 3D shape, it becomes a cylinder. And you can think about a piece of paper. If you take a piece of paper and you fold it around one of its edges, it will be a cylinder. So a rectangle will always become a cylinder. So I'm going to eliminate choices 1 and 2 because that's talking about a rectangular prism, but that's not what a rectangle becomes when you rotate it. It becomes a cylinder. So it's a rectangle that's 6 inches long and 5 inches wide. So let me draw this rectangle. And it's rotated around the longer side. So this would be the longer side. I'll just go over here because I have more space over here. The side's also 6. So it's continuously rotated around the longer side until it becomes a cylinder. So let me draw this. Doing my best to draw this. I am not a great artist. This would be the circular part here. This would be the circular part here. So here we would have a cylinder that is formed from the rectangle rotated around the longer edge. So we can see that the height is 6 from the top to the bottom, and we see that the radius is 5. So that would be answer choice 3, height of 6 and radius of 5. Okay, moving along. Number 7. A rectangle whose length and width are 10 and 6 is shown below. The rectangle is continuously rotated around a straight line to form an object whose volume is 150 pi. Which line could the rectangle be rotated around? So we know that no matter what we rotate it around, a rectangle is going to become a cylinder when it's rotated to become a 3D object. So we're talking about a cylinder here. Let's do these in order. So the long side, let's try that first. We rotate it on the long side. That's one circular part. That's the other circular part. Our cylinder will have a radius of 6 and a height of 10. So if we plug into the volume formula, that would be a radius of 6 and a height of 10. So let me put 6 squared times 10 into my calculator. And what I actually get is 360 pi. So answer choice 1 is not the one we are looking for. So I'm going to just erase so that we can try out another answer choice. Okay, a short side. So that's one of the short sides. So if we're rotating around the short side, here would be my cylinder. Okay, so the height would be 6. Oops. So as we can see here, when we're rotating it to become a cylinder, let me draw in my circle part. I'm a terrible, terrible artist. There we go. So as you can see here, the height is going to be 6 and the radius is going to be 10. Once again, I'm a terrible artist. So plugging in to my formula, radius this way will be 10 and height up and down will be 6. So let me put that into my calculator. That's 10 squared times 6. So that is actually going to be 600 pi. So that is also not the correct answer choice. So I'm going to erase so we can try out answer choice number 3. Okay, the vertical line of symmetry. So that means right in the middle. That doesn't look right in the middle, but hopefully you see it is right in the middle. So that would make, when we spin it around and around and around, that would make the radius 5 and the height 6. So let's try that out. Let me type in 5 squared times 6, and that is 150 pi. So that is the one that we're looking for. The horizontal line of symmetry means horizontally right in the middle, because then it makes mirror images on both sides. So if you rotate it around the horizontal line, the height's going to be 10 and the radius is going to be 3. You can plug that in and it wouldn't give you 150 pi. In the next example, we're talking about a rectangular prism and a prism with a square base, so 2 different prisms. And we're told that the volumes of the 2 prisms are equal, and we're looking for the height of the second prism. So for the rectangular prism, I know that for any prism, our formula is area of the base times the height. A rectangle, the area of the base is length times width times height. So that would be 25 times 9 times 12. And if I stick that into my calculator, that would be 2,700 cubic units. So that is for the rectangular prism. Now, the second prism, it's also a prism, so it has the same formula, volume equals to area of the base times the height, except it has a square base. So that means the length and the width are going to be the same. So the side length is 15, so that would be 15 times 15, which is the same thing as square times the height. We don't know what the height is, but we know that the volume is the same as the volume of the rectangular prism, which was 2,700. So all I need to do now is divide both sides by 15 squared so I can figure out the height. So let me divide by 15 squared, which is 25, and I get the height is 12 units. They don't give us units in the question. Okay. Moving along, the volume of a hemisphere that has a diameter of 12.6. So hemisphere is half of a sphere. So our formula is 4/3 pi r cubed. Let me find the radius. The radius is half of the diameter. So that's 12.6 divided by 2. So that is 6.3. Let me put this into my calculator. 4/3 pi 6.3 to the third power. And I got approximately 1047.4 cubic centimeters. So that's answer choice 2. And number 10, we're talking about a regular pyramid with a square base. So the volume of a pyramid is 1/3 area of the base times the height. And since we are talking about a square base, all the sides are the same. So the area of the base would be side squared. We don't know what the side length is, but we know the perimeter is 36. Since all sides of a square are equal, let's divide that by 4 to find what each of the 4 sides is. So each of the sides is 9. So I'm going to plug in 1/3, 9 squared. That's the length times the width of the base, the area of the base, times the height of the pyramid. Let me put this into my calculator. 1/3, 9 squared times 15. And I got 405 cubic inches as my answer. Okay, moving on to number 11. We have a paper container in the shape of a right circular cone. So I'm going to be using my cone formula, which is 1/3 pi r squared times height. So the radius is given as 3 inches, and the height is given as 8 inches. And it says to express our answer in 2 ways, in terms of pi and also to the nearest tenth. So first I'll do in terms of pi. I'm going to type into my calculator 1/3, 3 squared times 8, so everything except the pi. So in terms of pi, that is 24 pi cubic inches, or if I put pi now into my calculator and I round to the nearest tenth, that is approximately, 24 times pi. Let me redo that. That is approximately 75.4 cubic inches. So here is our answer expressed in 2 ways. Okay, number 12, we have a cylinder, and the diameter of the container is 13 centimeters. So we'll probably need the radius. Let me just divide that by 2 so I get that done. That is 6.5 centimeters, and height is 24 centimeters. Determine in terms of pi the volume of the cylinder. So that's in terms of pi. So cylinder formula is pi r squared times height. The radius is 6.5 and the height is 24. Plug this into my calculator. And it does say in terms of pi, so I'm not going to put the pi into my calculator. I'm going to just put everything else in. And I got 1014 pi cubic centimeters. And we are done with that one. Okay, moving on to the more complicated ones now. So here we have a wooden block that has a hole drilled in it. So there's empty space here that is not part of the block. The diameter of the hole is 2 centimeters. So the diameter of the hole is 2 centimeters. Calculate the volume of the solid. So we need to find the volume of the entire rectangular prism, the entire block, and then subtract out the empty space because the cylinder inside is empty space. So the volume of the whole block is, it's all in centimeters, so that's good, is area of the base times the height. Since it's a rectangular prism, the area of the base is length times width times height. So that would be 4 times 6 times 6. I'm going to put that into my calculator. 4 times 6 times 6, and I got 144 cubic centimeters. Okay, now we need to find the volume of the hole, and that's a cylinder, so that's pi r squared times height. So the radius is half of 2, which would be 1. Oops. Times the height of the cylinder, which would be 6. So that is 6 pi cubic centimeters. So now I just need to take my 144 and subtract off the empty space. I'm going to subtract the 6 pi, and I get approximately to the nearest hundredth, 125.2 cubic centimeters. So that's 125.2 cubic centimeters. Okay, moving on to the next one. In the diagram below, a right circular cone with a radius of 3 inches has a slant height of 5 inches. So that's not the actual height. Remember, height is measured by the altitude. So you can find the height of this right triangle using Pythagorean theorem. 3 squared plus b squared is equal to 5 squared. So that's 9 plus b squared equals to 25. That's b squared is equal to 16. Square root both sides. B is equal to 4. So the height is 4 of that cone. And a right cylinder with a radius of 4 inches and a height of 6 inches. Determine and state the number of full cones of water needed to completely fill the cylinder with water. So we got to find out how much the cylinder holds. So that's pi r squared height. The radius is 4, the height is 6. Let me put that into my calculator. That is 4 squared times 6. So that is 96 pi cubic inches. Okay, now I got to find out how much the cone can hold because I want to find how many cones can go into the big cylinder. So the cone formula is 1/3 pi r squared height. So plugging in, the radius is 3 and the height is 4. So let me put that into my calculator. 1/3, 3 squared. Oops, I typed that in wrong. 1/3, 3. I can't seem to type this in right. 1/3, 3 squared times 4. Okay, so that is 12 pi cubic inches. Now I just need to figure out how many of the cones can fit into the cylinder. So in order to do that, all I have to do is divide 96 pi by 12 pi. So let me do that over here. 96 pi divided by 12 pi to find how many of this can go in that. And that is 8. So the answer is 8 full cones. Okay, moving along. A rectangular tabletop will be made out of maple wood that weighs 43 pounds per cubic foot. Notice that there's two units attached to this 43, the mass unit and the volume unit. So that tells me that this number is the density. We have a density question here, and that's clear from the chart also because there's a density column. So it says that the tabletop will have a length of 8 feet, a width of 3 feet, and a thickness of 1 inch. Oh, that is some different units going on. Feet, feet, inch. So we should put this all in the same units in order to figure out what the volume is for our density formula. So I have two of them in feet. This is not going to convert well to feet. Okay, I guess it doesn't matter. I'll just convert this to feet because the other two are already in feet. So to get from inches to feet, we divide by 12. So 1 divided by 12 doesn't work out nicely, so that would be 1 divided by 12. So to find the volume of the tabletop, 8 feet by 3 feet by 1/12 of a foot. Let me put that into my calculator and see what that is. 8, 3, 1/12. And that works out nicely. Luckily, that is 2 feet cubed because I converted the 1 inch to feet by dividing by 12. So all of my units were now in feet. So that is 2 cubic feet. So let me plug into my density formula. So density equals to mass over volume. So we have 43 pounds per cubic foot. And we are looking for the weight, so we're looking for the mass. And now we have the volume. The volume is 2 cubic feet. So great, our volume units are the same, no more conversions needed. And our volume units cancel out when we cross multiply, which is good because we're finding the mass. So we just want to have our mass in the mass unit, which is pounds. So let's multiply 43 by 2, cross multiply. And that is 86 pounds is the weight of the tabletop. Oh, my bad. This chart does not go with this question. Oops. Let's cross that out. Always have an error here. So it's just the bottom part of the question. Yeah, that chart does not go with the question. So the answer here is 86 pounds. That is the mass. Okay. A cargo trailer pictured below can be modeled by a rectangular prism and a triangular prism. Inside the trailer, the rectangular prism measures 6 feet wide and 10 feet long. The walls that form the triangular prism each measure 4 feet wide inside the trailer. The diagram below is of the floor, showing the inside measurements of the trailer. If the inside height of the trailer is 6.5 feet, so the whole way through the trailer, the height is 6.5 feet, what is the total volume of the inside of the trailer to the nearest cubic foot? So at least this is nice. The height's in feet, all the other dimensions are in feet, and we are finding the volume to the nearest cubic foot. So at least no conversions are going to be necessary. So we basically have two parts of this trailer that we need to find the volume of and then put it together. Let's start with the rectangular base. So remember, the volume of anything can be found by area of the base times the height. If the base here is a rectangle, that would be length times width times the height of that whole part of the trailer. So the length and the width are 10 and 6, and the height throughout the whole trailer is 6.5. So let me put this into my calculator. Let me just get a little bit more space there. We have 10 times 6 times 6.5. And that is 390 cubic feet. Now we just need to find the volume of the triangular prism part. So we don't have the height, but luckily we know that this is 6 So 3 and 3. Let's find the height. So, oh, so let's find the height. Let me use my Pythagorean theorem. 3 squared plus b squared equals to 4 squared. So that's 9 plus b squared is equal to 16. So b squared is equal to 7. So b is radical 7. So our height is radical 7. Not such a nice number. That's okay. So let's find the volume of the triangular prism. Once again, the volume of any 3D solid can be found by taking the area of the base and multiplying by the height of the whole thing, the height of the whole trailer in this case. So since the base is a triangle, area of a triangle is 1/2 base times height. And then we still need to multiply by the height of the entire trailer. So let's plug in. In the triangle, the base is 6. The whole base is 6. And the height of the triangle is radical 7. And then we still need to multiply by the height throughout the whole trailer. And the height of the whole trailer throughout is given as 6.5 feet. So area of the base times the height of the whole 3D shape, the height of the whole trailer. And since the area of the base is a triangle, that's where I got 1/2 base times height from. That's our formula for area of a triangle when we are able to locate the base and the height. And in this situation, we are able to locate the base and height. So let me put this into my calculator. 1/2 times 6 times radical 7 times 6.5. And I want to keep a couple of decimal places to my very last step. I got 51.592 cubic feet. Now I'm just going to add the two volumes together. Let me add plus the 390 feet. And it does say to round to the nearest cubic foot. So I got 441.5 or 0.6, it really rounds to. So that is approximately 442 cubic feet to the nearest whole number. Here's our next question. So we have two figures. Figure A is a right triangular prism, and figure B is an oblique triangular prism. So one is slanted and one is not. The base of figure A has a height of 5 and a length of 8, and the height of prism A is 14. The base of figure B has a height of 8 and a length of 5, and the height of prism B is 14. So we can really quickly figure out what the volumes are, and then we'll answer the question, and we'll use Cavalieri's principle to explain why the volumes are equal. So just so we can see, we understand where Cavalieri's principle is coming from and what it's saying, to find the volume of any shape, we need to take the area of the base and multiply by the height. Since these are triangular prisms, the area of a triangle is 1/2 base times height times the height of the whole prism. So if I plug in for figure A, the base of the triangle base is 8, because we're talking about the area of the triangle base. So the base of that triangle is 8, and the height of that triangle is 5. And then the height of the entire figure is 14. And if we take a look at figure B, the area of the base is also a triangle. So that would also be 1/2 base times height times the height of the whole prism. On that triangular base, the base of that triangle is also 5, and the height of that triangle is also 8. And then the height of the entire prism is also 14. So notice that we're plugging in the exact same numbers. So of course the volumes are going to be equal. So Cavalieri's principle, and I'll just write what it is at the top so that we have it as a reminder. So Cavalieri's principle says that if two figures have the same base area and height, the volumes are equal. So here, figure A and figure B have the same base areas and the same heights, so their volumes are equal. Their base areas are the area of the triangle bases, which is 1/2 base times height, which was 8 times 5. So the area of the bases were both 20. I just put that into my calculator. And the height of both figures are 14. So let me put this over here. Since the base areas of both figures are the same, 20, and since the heights of the two prisms are the same, they're both 14, Cavalieri's, oops, I just spelled that totally wrong, principle says the volumes will be equal. There we go. Okay, moving on to the last question on this review sheet. And this one looks a lot more difficult than it actually is, but the question on the test is really similar to this. Definitely the part A. So it says a packing box for baseballs is the shape of a rectangular prism with dimensions 2 feet by 1 foot by 18 inches. So already I'm seeing different units. I'm seeing feet, and inches. So I know when I find the volume, because I'm probably going to have to find the volume, I have to put them all into the same units. Each baseball has a diameter of 2.94 inches. Determine and state the maximum number of baseballs that can be packed in the box if they are stacked in layers and each layer contains an equal number of baseballs. So basically I have a rectangular prism box. I cannot draw 3D shapes. And basically we're sticking baseballs inside the box. So we want to see how many baseballs can be packed in the box if we're stacking them on top of each other in equal layers. So I don't know if there's going to be this many. I was just making a visual of it. Then we're actually going to find out how many baseballs can be stacked. So that's basically the idea of what we're looking for here. So since it tells us the diameter of the baseballs in inches, I'm just going to put all the dimensions into inches. So 2 feet is 24 inches. 1 foot is 12 inches, and then we have 18 inches. So if I want to find the number of baseballs that can be packed in the box, I need to know how much space is in the box to start with. So the volume of the box is area of the base times the height. And since it's a rectangular box, the area of the base, which is a rectangle, would be length times width times the height of the box. So that would be 24 inches times 12 inches times 18 inches. And I'm going to put that into my calculator and see what the volume is in cubic inches. So that's 24, 12, and 18. So I got 5,184. But we know that the diameter of the baseballs is 2.94 inches. So that's the whole way across. So when we are stacking our baseballs in the box, depending on what the diameter is, that's going to determine how many we can stack. So that's going to affect the height, that's going to affect the length, and that's also going to affect the width. So maybe instead of multiplying these together right away, I should factor in the diameter of the baseballs. So I'm just going to take each of those dimensions and I'm going to divide by the diameter of the baseball because we need to figure out how many baseballs are going to fit with the length, the width, and the height of the box. So 24 divided by 2.94. And I'm going to round here. I got approximately 8.16. Let me divide 12 divided by 2.94. It's approximately 4.08. And let me divide 18 by 2.94. And that's approximately 6.12. So let me multiply these together. Oops, my bad. So we need to figure out the number of whole baseballs. So even though the diameter of the baseball is 2.94 inches, let's use 3 because we're talking about whole baseballs. My bad. So 2.94 rounds up to 3. There we go. Now when we multiply, that would be 8. Well, divide, I mean, that would be 4. And that would be 6. So now let me multiply together. I have 8, 4 times 6, and that gives me 192. So 192 whole baseballs can be stacked in the box. That is the maximum number of baseballs. So the reason I use the 3 once again instead of the 2.94 is because we want the maximum number of whole baseballs. So I just rounded up from 294 to 3 so we can talk about whole baseballs. Okay. So key thing to take away here that is going to be important on the test. If you want to find out like how much of something you can put on a shelf or in a box, take the length, the width, and the height, and just divide by the dimensions that you have. Okay. The weight of a baseball is approximately 0.025 pounds per cubic inch. There are 2 units here. So this is the density, mass unit, and volume unit. Determine in state to the nearest pound the total weight of all the baseballs in the fully packed box. So density, pounds per cubic inch, is equal to mass over volume. So I know that a baseball is a sphere. So the volume of the baseball would have the sphere formula, 4/3 pi r cubed. So that would be 4/3 pi. The radius of the baseball is the diameter is 2.94 inches. So I'm just going to divide that 2.94 by 2. And I got 1.47. So I'm going to put this into my calculator. 4/3 pi 1.47 to the third power. And I got about 13.306. I'm going to leave a couple of decimal places into the very last step, and that is in cubic inches because the diameter of the baseball was given in inches, so our radius is also in inches. So the volume unit cancels out, and we're left with the mass unit, which makes sense because we want the weight of the baseballs, and that will be in pounds. So let me multiply by 0.025 because we're cross multiplying, and that is about 0.3326 pounds. So that is the mass of one baseball. But we know in a fully packed box from part A, we can have 192 baseballs at maximum. So we do need to multiply that by 192. And that gives us the mass of the fully packed box. And it does say to the nearest pound. I got 63.8 on my calculator. So that is approximately 64 pounds of the fully packed box. And also another takeaway is that even if you can't do all of part A, you can definitely do some of it. Even if you didn't get part A fully right, you can still set up and complete most of part B. You can set up your density formula. You can find the volume of the baseball because the diameter was given to you in the question. And you can plug in and you can get almost to the end, to that very last step.